Hi guys, so today we're going to look at our last thing for the year, and that is just continuing what we did with trig last class. So what we're going to look at is the unit circle, but before we get there, I want you guys to see where these values in the unit circle actually come from. So the first thing we're going to do is we're going to review special right triangles like you learned in geometry. So there were two special right triangles. One of them was a 30, 60, 90 triangle. 30, 60, 90 triangles had a ratio of x root 3, and 2x. X was across from 30, x root 3 was across from 60, and 2x was across from 90. Your 45, 45, 90 triangle had a ratio of x root 2. So x could stand for any value. If you want the simplest value to plug in, would probably just be 1. So if I plugged in 1, this would be 1, this would be root 3, and this would be 2. If I plugged in 1, this would be 1, root 2. I can use any value I want for x. So we're going to look at these triangles with two different values plugged in for x. So to start, what we're going to do is we're going to use this special right triangle to determine the sine of 30 degrees without using a calculator. So again, we can plug in any value for x. So I'm going to go ahead and plug in 1. So this is going to be 1, root 3, and 2. And I'm just picking that because it's going to be the easiest numbers to work with. So sine, if you remember, is opposite over hypotenuse. So the sine of 30 degrees is going to be the opposite over the hypotenuse on my special right triangle, which is 1/2. The cosine of 30 degrees is the adjacent over hypotenuse, which is root 3 over 2. And the tangent of 30 degrees is the opposite over adjacent, which is 1 over root 3. Now, your teacher next year may want you to rationalize this. They may not. But if you did rationalize it, this would be root 3 over 3. So to find the sine of 45 degrees, again, we're going to go ahead and use that 45-degree triangle. So across from 45 is 1, root 2. So the sine of 45, the opposite over hypotenuse, is 1 over root 2. If you rationalized, that would be root 2 over 2. Cosine, the adjacent, is actually the same thing, which is root 2 over 2. And then tangent, our opposite over adjacent, is 1 over 1, which is just 1. All right, so sine of 60, we're going to go back to our 30, 60, 90, but again, sine is the opposite from that angle. So opposite of 60 is root 3, opposite, and then hypotenuse is 2. Cosine of 60, my adjacent to 60 is 1/2, and then my tangent of 60 is going to be opposite over adjacent, which opposite of 60 is root 3 over 1, which is just root 3. So our values for our trig functions we actually can find using these special right triangles. So now we're going to do a couple others. So some things that will be very helpful to know both for your unit circle but also for what we're about to do here. Pi over 6, if we converted that to degrees, is going to be 30 degrees. Pi over 4, if we convert it to degrees, is 45, and pi over 3 is 60. Those are three of the most common reference angles you're going to see. So pi over 6 is not just 30 degrees. Any pi over 6 value is going to have a reference angle of 30 degrees. So if this is 11 pi over 6, the reference angle will be 30 degrees. If this is 15 pi over 4, it's going to have a reference angle of 45 degrees. So what we need to determine then is which quadrant will it be in, and that's why we did the work we did yesterday. So if I want to find the sine of 210 degrees, so I'm going to label 210. 210 is past 180, so it's going to be in quadrant 3. The reference angle, if this is 210, the distance between those, that reference angle is 30. So I can still fill in my special right triangle. On that special right triangle, if this is 90, across from 30 is 1, across from 60 is root 3, and the hypotenuse is 2. But because of the quadrant that this is in, this is actually a negative root 3 and a negative 1 because of where I'd be plotting that point. Now that my triangle is filled in, I can go ahead and find the opposite over hypotenuse in this picture. The opposite of the reference angle is negative 1, and the hypotenuse is 2. So the sine of 210 degrees is negative 1/2. Let's try a radian value. So the first thing we need to determine is which quadrant this is in. That's what we did last class. So all the way around, one pi would be 6 pi over 6. So we're not quite there, but we're closer to 1 pi than we are to 0. So 5 pi over 6 is going to be in quadrant 2. The reference angle for any pi over 6 is 30. I'm going to make this a little bit bigger so you guys can see this better. There we go. So we're in quadrant 2. Our reference angle is 30. And again, reference angles are next to the x-axis. So make sure if you draw this, we draw it connected to the x-axis. So now on my 30, 60, 90, across from 30 is 1, across from 60 is root 3, and across from 90 is 2. Based on which quadrant this is that root 3 should be negative because it's going in the negative x direction. The 1 can stay positive because if I were to plot that, I would be going up in the positive direction. So now based off this picture, I'm going to find the cosine ratio, which is the adjacent over hypotenuse, which is negative root 3 over 2. All right, the last one we're going to look at is a tangent value. So again, we need to determine which quadrant this is in. 3 pi over 4 is less than 1, but it's closer to 1 than it is to 0, so it's going to go in quadrant 2. The reference angle for every pi over 4 is 45 degrees. So that's going to go in quadrant 2. I'm going to fill in my ratios. This is 1, 1, root 2. Across from this 1 down here should be negative because of the direction it's in. Tangent is opposite over adjacent. So the tangent of 3 pi over 4 is negative 1. So if you draw these triangles and you remember your reference angles, you can find all of these trig values. Now, the only ones you would not be able to find are the ones that actually fall on the line. So what we're going to do is we're going to look at something called a unit circle. So the unit circle is going to give us another way to be able to find these values. And if you can remember it, it actually will make it a little bit faster to find these values. But if you ever forget these points in the unit circle we're about to find, this is another way that you can work back to find what these values are. So what we're going to do is we're going to look at our same 30, 60, 90, and 45, 45, 90 triangles. It's going to have that same ratio. It's x, across from 60 is x root 3, across from 90 is 2x. But this time, instead of filling in 1 for my x, I'm going to make my hypotenuse equal 1. So if the hypotenuse is equal to 1, that means that on this triangle, x is equal to 1/2. So if I fill that in, if x is 1/2, this is 1/2. If x is 1/2, this is 1/2 times root 3. And then we just said our hypotenuse was 1. So this is still a 30, 60, 90 triangle. It's still the same ratio. It's just a different value plugged in for x. So same thing, 30, 60, 90 triangle. Again, I'm going to fill in 1 across. If 1 is equal to 2x, then x is equal to 1/2. Across from 60 would be root 3 times x. That's root 3 over 2. And this is going to be 1/2. There's a reason I have both these triangles on here. We're about to look at them. Then 45, 45, 90 has a ratio of x, x, x root 2. So in this case, I get that x root 2 is equal to 1. So that means that x is equal to 1 over root 2. 1 over root 2, if you want to rationalize it, I can multiply by root 2, top and bottom, and that gives me root 2 over 2. So my hypotenuse here is just 1, but now my sides are root 2 over 2. So this triangle, again, it's the same ratio, it's just different values. I can still find these things the same way I just did. So for example, if I want to go back and I want to find the sine of 30 degrees on this triangle, my opposite over hypotenuse is 1/2 divided by 1. If I divide by 1, it's still 1/2. So even though it's different values, I'm still getting the same answers. If I want to do the tangent of 45 degrees, I'm going to do opposite over adjacent. Well, root 2 over 2 divided by root 2 over 2 is just 1. It's the same thing I got with the other ratio. The reason we want to look at these ratios, though, with a hypotenuse of 1 is for something called the unit circle. So the unit circle is basically a circle where the radius is 1. And that's why we filled in these triangles with a radius of 1 on them. Now, over here, it says very important. These are the things you really need to know in order to use the unit circle. So whenever we were doing sine, okay, sine was the opposite over hypotenuse. Actually, let me go ahead and fill in these values for you first, things to make it easier to see. So I'm going to take that 45, 45, 90 triangle. It has a hypotenuse of 1. I'm going to put it on top of our circle. So what I did was I filled in those same values that were on there. I think I left them not rationalized, but this value was root 2 over 2, and this value was root 2 over 2. What that means is this point on my circle, if the radius is 1, at pi over 4 radians, or 45 degrees, that point, if I were to plot it, would have an x-coordinate of root 2 over 2 and a y-coordinate of root 2 over 2. All right, so now I'm going to go ahead and move my other triangle. Let's go ahead and move my 60-degree triangle. So this one has a reference angle of 60 degrees. So it has a reference angle of 60. And if I were to plot that point there, if you look, I've gone over a distance of 1/2, and I've gone up root 3 over 2. The only thing is I haven't gone over a positive 1/2, I've gone a negative 1/2. So again, the reference angle gives us that same absolute value, but because of the direction where it is, it's going to be a negative. And then the last one I'm going to move is this 30-degree. So that's a 30-degree reference angle. So I'll put this one over here in quadrant 4. So again, we've already filled in those values. So my side-to-side distance, I've gone over root 3 over 2, and then I've gone down negative 1/2. So how these values relate to those trig functions we just found. The sine value of this reference angle is the same thing as the y-coordinate of those 2 points. The cosine that we just found is the same as the x-coordinate of those points. And the tangent value that we found is the y-coordinate divided by the x-coordinate. So sine is our up and down, because if we're talking about a reference angle, let's think about this. Reference angle is this angle right here. Sine is opposite, and the opposite is the distance that's going up. The adjacent is the distance going to the side. That's why sine is our y and cosine is our x. Tangent is sine divided by cosine. That's going to come up a lot next year. So it is opposite over adjacent, so it's the vertical distance divided by the horizontal distance. So if you're going to be using the unit circle, you've got to remember sine is the y, cosine is the x. So what we're going to do is we're just going to go in and we're going to fill in all of these coordinates. So we said that the radius here was 1. That's why this point here on the outside is just 1, 0. Pi over 6, now let's go ahead and fill in the other ones that I raised. So this was root 2 over 2, root 2 over 2. This here was negative 1/2, root 3 over 2. So each of these that has a different color has a different reference angle. So what I'm going to do is I'm going to fill in the ones that have a similar reference angle. So 3 pi over 4, that has a 45-degree reference angle. So it's going to have the same coordinates. The only difference is going to be the positive and negative signs. Because it's in quadrant 2, I've gone in the negative x direction and a positive y direction. All right, another one with the same reference angle is 5 pi over 4. 5 pi over 4 has the same values, but we need to put our signs. So these are both negative because I've gone to the left and I've gone down. And then the last one with the same reference angle would be 7 pi over 4. So 7 pi over 4 is a positive root 2 over 2, but a negative for the y-coordinate. So again, it's the same absolute value. The only difference is where the positives and negatives are. So every pi over 4 radian that you get is going to have that same x and y coordinate. That's why it's really important to be able to determine which quadrant it's in. Because if you know the quadrant, then all you need to figure out is if it's positive or negative for the x or the y. All right, so let's try the blue one. So the blue triangle has a reference angle of 30. That is all of our pi over 6 radian values. So pi over 6 is going to have the same x and y coordinate. It's still over root 3 over 2 and up 1/2. 5 pi over 6, that is still over negative root 3 over 2, and it's a positive 1/2. 7 pi over 6, negative root 3 over 2, negative 1/2. And then we've already filled in our 11 pi over 6, which is root 3 over 2, 1/2. All right, so our last one then is the red triangle, which is the 60-degree reference angle, which is the pi over 3. So pi over 3 is going to be 1/2 root 3 over 2. In quadrant 2, the x-coordinate is negative. And then in quadrant 3, this is the same value, so it's a negative 1/2, negative root 3 over 2. And then in quadrant 4, it's a positive 1/2, but a negative root 3 over 2. So those are all the coordinates of your unit circles. The other points, make sure we notice all of these quadrantal angles are 0s and 1s. Okay, all these quadrantals are 0s and 1s because the radius here is 1. So the coordinates of this point is 0, -1. If you were to go over 0 and down -1. Over here at pi, the coordinate is -1, 0 because I've gone to the left 1 and up 0. So what's important to know whenever you guys fill in your unit circle, you're going to need to know these coordinates, but you're also going to need to know those radian values. So it's really important to be familiar with where these radian values are. So if you notice, all the ones that are closest to the x-axis are all pi over 6 values because they all have reference angles of 30 degrees. All of the ones in red are the closest to the y-axis because they all have reference angles of 60 degrees. Some other things to notice, if you look in quadrant 2, all of those radian numbers, all of the numerators are 1 less than the denominator. Look at all the radian values in the third quadrant. All of the radian values are 1 more. All the numerators are 1 more than the denominator. So if you're having trouble remembering what those radian values are, that's some little tricks. Another way to find these values, let's look at our pi over 4 values. So if I count, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So if you count by 45 degrees, each one is a pi over 4. Some of them we just reduce. And then one last thing we can do is we can look at our 60-degree angles as well. So if I count by 30s, so pi over 6 is our first one. 2 pi over 6 would be 1 pi over 3 if I reduce it. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So again, if you keep counting and reduce, 7 pi over 6, 8 pi over 6 is the same thing as 4 pi over 3. 9 pi over 6 is the same thing as 3 pi over 2. 10 pi over 6 and 11 pi over 6. So that's another way to help you remember what those radian values are. You guys are going to be using these a lot next year though, so the more you see them, the easier they're going to be to remember. All right, so what we're going to do now is we're actually going to use those values to answer some questions. Now, one thing you can do to help you remember which ones are positive and negative, there is a little acronym to help you, and it is all Smarties take calculus. So it goes in quadrant order. All Smarties take calculus tells us which trig functions are positive. Which ones are positive? So they are all positive in quadrant 1. In quadrant 2, sine and its reciprocal cosecant, we'll get there, is also positive. In quadrant 3, tangent and its reciprocal are positive. In quadrant 4, cosine is positive. Which again, if you think about it, it makes sense because sine is positive because any point in this quadrant is going to have a positive y-coordinate. In quadrant 4, any point that I plot is going to have a positive x-coordinate, and x is cosine. Anything in quadrant 3, tangent, that's going to have a positive slope because it's a negative x and a negative y, but if I do a negative divided by negative, I get positive. All right, so to actually answer those same questions we were doing earlier, all I need to do is determine the coordinates. So the cosine of pi over 2, that is saying what is the x-coordinate at pi over 2. So pi over 2 on my unit circle was up here. That point, if I were to plot it, would be 0, 1. The x-coordinate is 0, so the cosine of pi over 2 is 0. The sine of 11 pi over 6. So 11 pi over 6, I look at my unit circle. So on the unit circle there, the coordinates of that point were root 3 over 2, negative 1/2. Sine is the y-coordinate, so the y-coordinate of that point would be a negative 1/2. tangent of 2 pi over 3. So I would look at my circle at 2 pi over 3, and I would find those coordinates. So that one should be 1/2, negative 1/2 root 3 over 2. Tangent is y divided by x. So this is root 3 over 2 divided by negative 1/2. So when I divide, oops, that should say divided by, I haven't multiplied yet. I'm going to flip my second and multiply. The 2's cancel, and I'm left with negative root 3. Again, this is actually the same thing you would get if you drew this triangle. So if I drew a 60-degree reference angle in quadrant 2, and I filled in my values, root 3, 1, and 2, my opposite over adjacent is still negative root 3. So if you forget those points on your unit circle, you can always go back to determine your values this way. And the last one, the reason we looked at which quadrant a radian fell in was for a question like this. Negative 11 pi over 3 is not on my unit circle, so I need to find an equivalent coterminal angle. So I'm going to take negative 11 pi over 3 and add 2 pi. All right, not quite there, so I'm going to add it again. And I can see that that is coterminal to pi over 3. That means the cosine of negative 11 pi over 3 is going to be the same as the cosine of pi over 3. So all I need is the x-coordinate at pi over 3. And the x-coordinate at pi over 3 should be 1/2 root 3 over 2. So my x-coordinate is 1/2. All right, so that is it. Hopefully this helps you guys get a little bit of a preview of what you guys are going to see next year in pre-cal. So again, I would recommend taking your time understanding the values that are on the unit circle, because they're going to come back over and over and over again in pre-cal and in calculus.